So we've been talking and looking at patient 23, and it's likely that patient 23 has food poisoning because of the bacteria C. jejuni. So at the end of week 3, we know that he was treated with antibiotics. And when we look at this chart that shows at week 5, and we think about as this patient was treated with antibiotics, we notice the patient is feeling well again, but we also notice that the pie chart looks different. So what do you notice about the pie chart? You probably noticed that the number of microorganisms that the patient has been reduced. The reason it's been reduced is because of the antibiotics. If we look at week 7, so here we were at week 5, and now at week 7, the patient is starting to feel sick again. So here the patient is feeling well, took the antibiotic, and now we have a new type of bacteria. And if we look here at this key, we can see this new bacteria that shows up as red for the key. This harmful type of bacteria is called C. difficile. So if we think about C. difficile and we reference back and think about our chapter 2 question, and the question is, how can fecal transplants cure patients infected with harmful bacteria? When we think about this, we need to have a little bit of information. So there's about 500,000 people that get infected with C. difficile in the United States every year. And actually, thousands of people die from the infection. And the reason is because the infections are very hard to treat. But this new fecal transplant procedure has actually shown promise, and it's been used as a treatment for patients, and it potentially has been helping people with this life-threatening bacteria. So let's think about what we learned in lesson 2.3 and also the relevant and irrelevant activity that we did together. What we discovered is that antibiotics reduce the number of helpful and harmful bacteria that we have in the microbiome. So understanding that key concept also leads us to asking another question. So how can having fewer than normal bacteria in the gut microbiome, how can that affect the overall health of the body? So this is what we want to be thinking about as we look at new information. So we're going to actually look at an experiment that was done with mice. So we might be thinking, why would we use mice? Why not a dog or a cat? So let's take a look and compare a mouse and their gut microbiome to a human. So here we have two charts. The normal human gut in a person looks like this. And in a mouse, this is what shows up for the gut microbiome. So what do you notice? What is similar? What is different? Well, when you look at the type, you can see that we have the same type of bacteria. Also, look at how much there are. We pretty much have about the same, potentially, this one looks a little bit different here, but it's pretty much pretty close to having the same amounts of bacteria in a human gut as compared to a mice's as to a gut from a mouse. So we have a lot of the same proportions as well of the similar bacteria. So what we want to do and what we want to think about is, what patterns can we see in the data? How can looking at patterns help us to identify causes and effects of having fewer bacteria in the gut microbiome? So scientists wondered, okay, is a low bacteria gut microbiome, is that making the mice more vulnerable to a salmonella infection? And so salmonella is a type of bacteria, and what they did is they did an investigation with 40 lab mice. So we have 20 healthy mice and 20 that have low bacteria in their gut. And if we take a look at these two examples here, if we take the 20 and they basically had the mice eat something that had the bacteria, and what we found out was 5 of the mice were fine, they didn't get sick. 12 got a little sick from the salmonella infection, and 3 got really sick. And those were the mice that had a normal gut microbiome. But take a look here at those that had low bacteria. 20 of these mice, so all of them, got really sick from the salmonella. So we can tell that both groups were healthy at the beginning, but then after they ate the salmonella bacteria, then we didn't have the same results. So what we want to be thinking about is, why do we think this happened? What caused this group of bacteria to get really, really sick?